How to convert a decimal number to a hexadecimal number. In this tutorial, we will describe how to convert a decimal number to a hexadecimal number. For example, let us convert the following. Alright, for this example, we're going to convert a decimal number to a hexadecimal number. For this example, we will use the decimal value 475 and we will convert it to a hexadecimal representation. In this case, our expected value would be 1dB. Now, we have some notes to the right. We start off with 16 to the fifth power is 1,048,576. We have 16 to the fourth power is 65,536. We have 16 to the third power is 4,096. We have 16 to the second power is 256. And we have 16 to the first power, of course that's 16. And anything to the 0th power is 1. We will use this in the computation. Since we're converting from decimal to hexadecimal, the key to this computation is we will divide the decimal value by 16. Alright, so let's begin. So we're going to take the value 476 or 75, my mistake. And what we're going to do is divide 475 by the highest multiple of 16. So this is why we have the notes towards the right. So 475, let's see, 4,096, that'll be 16 to the third power, is greater than 475. So we can't use that one, so we're going to use the one right below it. So we have 16 to the second power is 256. So we'll take that and divide into 475. So let's see what we get. Let's see, it's 256. So 475 divided by 256, it will be one time. So let's put 1 here. And then we have 256 times 1 equals 256. So now we take 475 and subtract 256. And this will leave us with a value of 219. So let's indicate that, okay, when the division produced a quotient of 1. So I want to indicate that here as 1. But let's, at this point, indicate it that this is still in decimal form. All right, so our next computation. Let's look at the 219. We're going to take a multiple of 16, the highest multiple, and divide into 219. Alright, we saw that 16 to the second power produces the value 256, and that's greater than 219. So we want to take the next one below. So we look at 16 to the first power. That fits the description. So 16 is going to divide into 219. Let's see what we produce. 19 divided by 16. And that's 13 times. So we have 16 times 13. And that's going to equal 16 times 13 is 208. And then we show 219 subtract 208. And this will give us a difference of 11. So we move the 13 over, still in decimal form. So this is 13, and we say at this point it's represented in decimal form. So the next difference here we have is 11. Okay, so we say that the next multiple of 16, we want to divide the highest multiple of 16 into 11. Well, we already showed that 16 is greater than 11. So the next possible value is we have to take 16 to the 0th power. It produces the value 1. So we divide 1 into 11. Of course, that's 11 times, but let's just follow a computation. 11 times 1 equals 11. And then we subtract 11 from 11, and that will produce the value 0. This just triggers red flags right here. We've got, when we hit the 0 right here, a difference of 0, this is our stopping point. So there's no need to do any more computation. So we'll go ahead and indicate that the 11, we'll move it over here, is still represented in decimal form. Okay, so let's convert each of these to hexadecimal. So we have the value 1 in decimal. Its representation in hexadecimal is 1. Alright, so we look at 13. 13 is represented in hexadecimal by the value D. And then we look at the value 11, we convert it to hexadecimal. In hexadecimal is represented by the value B. And thus this shows we have the value 475 in decimal is represented in hexadecimal by the value 1 D B. And this is what we wanted to show. Next, let us perform another decimal to hexadecimal conversion. This time we will convert numbers with a decimal point. Okay, so we begin another conversion. We're going to convert a decimal number to hexadecimal number. This time we have a value that has a decimal point. You will see we will use the same algorithm, but when we actually deal with the integer portion, we will continue to use division. We will divide by 16 since we are trying to convert a decimal number into a hexadecimal number. And you'll see that when we get to the fractional part, the 0.75, we will have to do the inverse of division, which will be multiplication. We will continue to use the numbers to the right, which we have 16 to the 5th power, all the way down to 16 to the 0th power. It will come in handy. So let's begin the computation. So let's focus only on 491. Start with that first. So what we'll do is we will divide the highest multiple of 16 that's less than 491. Okay, so in this case, once again, we see that when we deal with 16 to the 3rd power, the value 4096 is greater than 491. So we'll step down and use the 16 to the 2nd power, which produces the value 256. So we will divide 256 into 491. So let's see what we... with the value 1. And we have 256 times 1 equals 256. And so we take 491 and subtract 256 from 491. And this will produce a difference of 235. Alright, so let's go ahead and indicate this as we did previously. We just want to show that the 1 in this case is still in decimal form. Alright, so we have our next difference, which is 235. And we want to take, once again, the highest multiple of 16 without going over 235. We show that, or we know that 256 is greater than 235. So we'll take the next available value or multiple below, which would be 16 to the first power, and this produces the value 16. So 16 we will divide into 235. Okay. So 235 divided by 16, it's 14. So we have 14 here, and 16 times 14, we have the value 224. And so we take 235 and subtract 224, which produces the difference 11. So before we begin the next computation, let's go ahead and indicate here 14 is represented in decimal. So once again, we have the value 11, and we want to take the highest multiple of 16 without going over 11. So we can't use 16 to the first power because that's the value of 16, and 16 is greater than 11. So we take the next one, which is 16 to the 0th power, and that produces the value 1. So we divide 11 by 1, and we, of course, it would produce a value 11. 11 times 1 is 11, and when we have 11, subtract 11, it produces a difference of 0. And once again, because we have value 0 here, that means we can stop. There's no more computation. So let's go ahead and indicate the 11 here as in decimal form. Okay, so next we do is we could at this point go ahead and let's go ahead and convert these to hexadecimal. So 1 in decimal, its representation in hexadecimal is 1. So we take 14 in decimal, and its value in hexadecimal is the letter E. We convert 11 to hexadecimal, its value is B. And what this shows right here is we perform the integer portion by dividing by 16. Okay, so when we get to the fractional part and we have that value is 0.75, we're going to use the inverse of division, which is multiplication. Okay, so we multiply. So we multiply by 16, and so this produces a value of 12. And we can say here that 12 is represented in decimal form, and when we convert this, its hexadecimal representation is the value C. So we can let this line here pretty much represent the decimal point. So what this shows is that we have the value 491.75 in decimal is equal to 1 E B point C in hexadecimal. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe how to convert from decimal numbers to octal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.